Welcome everybody to this lecture where we want to solve the so-called principal-agent conflict. Let's have a look at the setting. There is a principal which has a company, but this person does not want to manage it himself or herself. So for example, we are talking about a management succession through inheritance. Does that kind of stuff happen in the real world? Yes. For example, there was an entrepreneur called Gustav Abraham Schickedanz. He was a very successful entrepreneur. He found the mail order company Quelle, and it was the case that in the end, the only daughter of Gustav Schickedanz, like Madeleine Schickedanz, took over this company, but Madeleine Schickedanz was not able to manage this company, and therefore she was hiring a manager, and the manager is the agent. So the principal hires an employee. The employee is the agent, and the agent should manage the company. So the principal owns the company, but the agent has to run the company on an everyday basis. The principal cannot always stand behind the agent and observe how long and how hard the manager works. Otherwise, the principal could do it himself or herself. This implies monitoring is not possible. The principal cannot monitor the action of the agent. The agent would like to agree a fixed salary, and afterwards the agent would not work at all because work is associated with disutility of effort and therefore comes only with some cost. The agent would take the fixed salary and would not work at all afterwards. Therefore, the output would be equal to zero, the revenues would be equal to zero, because of the fact that the agent would not start to produce some output. The principal would pay a fixed salary, but would not receive any return. Therefore, the profit for the principal would be smaller than zero. The profit would be negative. The principal would make a loss. Does that kind of stuff happen in the real world? Yes. Let's have a look once more at Madeleine Schickedanz, the principal, and the principal hired an agent like this manager here. His name is Middelhoff, and it is the case that this guy was not a good manager, so the principal did not hire a good manager, or the principal did not set up a very good contract, so the principal did not solve the principal-agent conflict. In the end, the company filed bankruptcy, and the principal says that now I have to live on 600 euros a month, and Madeleine has to buy vegetables at the discounter. So in case that this principal-agent conflict is not solved, it is a case that the principal has a problem. Therefore, it is very important that we go through the next slides and that we can learn how the principal-agent conflict can be solved. The solution for the conflict between the principal and the agent is that the principal not only offers a fixed salary F, but also a share in the company's return. The variable S symbolizes the share which goes to the agent. In case that the agent works, then the agent produces an output, the return would be positive, and the variable component of the salary would increase. In case that we set up that kind of contract, the interests of the principal and the agent are aligned by the variable part of the remuneration contract. Let's have a look at the profit function of the agent. The profit function of the agent pi a is determined by three different components. There is a variable component of salary, like the agent receives the share S of the output, which is given by rho times E. So rho times E, this is the output. E once more symbolizes the number of hours worked. Rho is the amount of products which can be created in 1 hour of working time. So rho times E, this is the output. And then the agent receives the share S from the output. Furthermore, it is the case that the agent receives a fixed component plus F. Receives is highlighted here because in the end it will turn out that this fixed component takes a very specific value. Furthermore, we assume that working in the factory needs some effort, and this effort generates cost. And we assume the same cost function as we know already. 1/2 E squared symbolizes the cost function. We have to consider the so-called participation condition. The agent will only sign the work contract in case that his profit is not negative. So the profit of the agent has to be larger or equal to 0. Only then the agent will sign the contract. The employment contract is defined by the principal as a so-called take it or leave it offer. So no initial negotiations are going on between the agent and the principal. The principal has to set up the contract, and then the agent checks whether the profit is not negative, and then it will be the case that the agent will sign the contract in case that the participation condition is fulfilled. The agent can only determine his amount of hours worked, so the agent is deciding with respect to the effort. The agent has to maximize his own profit by the optimal choice of the effort level, so the agent has to decide how many hours do I work in the factory. Let's have a look at the profit function of the principal. The profit of the principal is given by two components. There is a variable component of the return. Return once more is given by E times rho. And then the share 1 minus S goes to the principal. We mentioned before that the share S goes to the agent, so 1 minus S stays with the principal. Then we have to think about the fixed component. The principal pays the fixed component, therefore in the profit function it pops up with a negative sign because it is a cost component for the principal. The principal knows the profit function of the agent and anticipates the behavior of the agent. The principal knows the best response of the agent and takes the behavior of the agent into account when he sets up the contract offer. A very important point here that there is no uncertainty at all. We don't have any risk in this model. There is no uncertainty, and therefore differences in the risk attitudes between principal and agent do not matter here. The principal has to maximize his own profit function by choosing the optimal share S in knowledge of the agent's reaction function. So the principal has to set up the contract, and in this contract it has to be written down what is the optimal share S. The time structure of this problem is as follows. In a first step, the principal sets up a contract and offers the agent an employment contract with a fixed and a variable component. The agent accepts the contract in case that his profit is not negative. So the agent has to check the participation condition, has to check whether the profit of the agent is not negative, and then he will sign the contract. Afterwards, the agent reacts with the optimal work or effort. So the agent decides how many hours do I work in the factory. This is not under control of the principal. The principal cannot write down you have to work 10 hours because then the principal would have to monitor the agent whether the agent is indeed working 10 hours. And we ruled out that monitoring is possible. The principal doesn't want to stand behind the agent and check how many hours is the agent working. So the effort level E is under control of the agent. When the agent reacts with the optimal work effort, we call it the agent is giving the best response, or we can also call it the incentive constraint. Afterwards, the agent receives the fixed and the variable component as a salary. In the end, the principal receives the residual income, like the output, which is created minus the fixed component minus the variable component of the salary. The principal's problem is the principal wants to maximize his own profit. The principal wants to maximize the residual income. But the residual income depends on the agent's behavior, so that the principal has to form expectations about the agent's behavior. So now that we have defined the problem, it is time to solve the problem for the principal. The problem is on the side of the principal because the principal has to set up the right contract, and the problem can be solved by so-called the backward induction method. Step 1 is the principal has to put himself into the position of the agent and has to maximize the profit of the agent. In this way, the principal learns the behavior of the agent. With step 1, the principal learns the so-called best response function. The principal learns the incentive condition. In a second step, it is the case that the principal has to undress the agent. The principal calculates the limit, how much salary needs the agent so that the agent still signs the contract. The principal has to calculate the participation condition. In a third step, the principal optimizes his own profit function under consideration of the behavior of the agent, the incentive and the participation condition. So, in the end, the principal has to select the optimal share S for splitting up the output. Let's perform the different step. Let's start with step number 1. The principal has to anticipate agent's behavior. Therefore, the principal has to put himself into the shoes of the agent and has to maximize the profit function of the agent, because then the principal learns how the agent behaves. The profit function of the agent is given here. What is under control of the agent? It is the effort level, the amount of hours the agent is spending in the factory. So we have to differentiate here the profit function of the agent with respect to the effort level. And when we do that, we get this relationship here, like S times rho, because there is one E. When we differentiate with respect to this E, we get S times rho. And when we differentiate with respect to this E here, then we get a minus E. Therefore, we get this relationship here. The number of hours worked by the agent is equal to S times rho. The agent will spend S times rho hours in the company, and the principal now will take this best response of the agent into account when he calculates the participation condition. The principal has to answer the question, how much salary does the agent need in order to sign the contract? Let's have a look at step number 2, where the principal computes the participation constraint. The agent will still sign the contract in case that the profit of the agent is equal to 0. This is the limit. Agent's profit should not become negative, because then the agent will not sign the contract. The principal has to determine the optimal amount of the fixed salary by inserting the incentive constraint into the participation constraint. So we have to insert the previous result, E is equal to S times rho, into the profit function. Let's do that. So we have an E here, and we can insert S and rho in this profit function of the agent. So we find here the S and rho. And then we also have to insert S times rho in this part of the profit function, which can be seen here. Now it is the case that we have to set the profit function equal to 0. Not the first order condition, but the profit function has to be set equal to 0. Because of the fact that now we want to undress the agent. The agent should not get a positive profit, but the profit should be equal to 0. In the next step, we have to solve equation 12 for f, and then we know the fixed component. Let's do that. We have to solve this relationship for f. So in the first step, we get rid of the brackets. We get S rho times S rho is S squared rho squared. There is the f for the fixed component. And then also we can get rid of this bracket here. We get S squared rho squared. We want to solve this relationship for f. So we put S squared rho squared on the other hand side of the equation. It pops up with a negative sign here. When we put this 0.5 S squared rho squared on the other hand side of the equation, it pops up with a positive sign here. Then we can combine these two terms. We have a positive S squared rho squared here, and we subtract. We have a positive 0.5 S squared rho squared here, and when we subtract this S squared rho squared, we get a minus 1/2 S squared rho squared. This equation 13 is very important. It's in red ink here. It indicates when we look at equation 13, it becomes clear that the fixed component of the salary is negative. This implies that the agent has to bring money to the gate of the factory in order to get the permission to work. So in the morning, it is the case that the principal waits in front of the door of the factory. The agent arrives and already brings the fixed component with him, and the agent pays the principal in order that the agent is allowed to work in the factory. In the last step, we have to determine the optimal share S. We have to insert all the information which we know in the profit function of the principal. So we have to insert the incentive constraint, and we also have to insert the participation constraint into the principal's profit function. Let's do so. Like we know that the effort level is equal to S times rho. When we insert S times rho for this E here, we get this relationship here, S rho squared. So we are inserting S rho in this relationship, and we get S rho squared. And then in the profit function of the principal, there is this fixed component. So we have to insert the participation constraint into the profit function of the principal, and then we get here like a positive 0.5 S squared rho squared. When we get rid of the brackets, we get the relationship 1 times S rho squared, so S rho squared here, and then minus S squared rho squared. Minus S squared rho squared is equal plus 1/2 S squared rho squared. The principal wants to determine the optimal share S. The principal, when he sets up the contract, he can decide what the optimal share is, and this is under control of the principal. Therefore, we have to differentiate the profit function with respect to S. When we do that, we get this first order condition here. So we differentiate with respect to that S, we get rho squared. When we differentiate with respect to this S squared, we get minus 2S rho squared. And when we differentiate with respect to this S squared, we get S rho squared. This has to be equal to 0, which gives the first order condition. Let's solve this relationship. Like we have a negative, or we have 2 negative S squared rho squared here. When we combine this term, we have 1 negative term S rho squared on the left hand side. When we put it to the right hand side, then we get rho squared equal to a positive S rho squared. Now we can divide both hand sides of equation 17 by rho squared, and we get the information that S is equal to 1. So it is the case that the share S is set to 100%. The variable component of the salary comprises the entire return. All of the stuff which the agent is producing in the factory goes into the pocket of the agent. So the agent pays the fixed component F to the principal at the gate of the factory, and afterwards the agent is allowed to do whatever he wants and is allowed to reap all the fruits he sows. This is the solution of the principal-agent conflict. So S is set equal to 100%. In the third part of this lecture, I would like to compare the basic scenario with the principal-agent conflict. So in the second part, in equation 11, we were able to derive the relationship that the effort level of the agent depends on the share and the marginal productivity rho. With S is equal to 1, we get to the relationship that the effort level is equal to rho. This implies that equation 11 matches with equation 4, so the agent spends also rho hours in the factory. In the numerical example, we assume that rho is equal to 10, so the agent is spending 10 hours in the factory. And this is the same amount of hours compared to the principal who is working in his own company in the basic scenario. So the agent acts in the same way as the principal in the basic scenario, and the agent works as much as the principal if the latter would run the company by himself. What about the profit of the agent? We have the following incentive constraint. The effort level depends on the share and row. With the insight that S is equal to 1, we once more get to the incentive constraint that the effort level is equal to rho. Furthermore, we were able to derive the participation constraint, and from the participation constraint, we got the result for the fixed component of the salary. The fixed component of the salary was given by F is equal to minus 0.5 S squared rho squared. In case that S is equal to 1, we get the insight that the fixed component is equal to minus 0.5 rho squared. When we insert the incentive constraint and the participation constraint in this profit function of the agent, we get under consideration that S is equal to 1. S equal to 1 in the profit function of the agent times rho times this E here, but E is equal to rho. So we get this part here, and then it is the case that the fixed component plays a role in the profit function of the agent. We have to add the fixed component, but the fixed component in itself is negative. So this is the fixed component. And then we have to consider that accelerating effort leads to some cost on the side of the agent, which is reflected by this last component here. Let's check how large the profit of the agent is. Like we have here a rho squared, and then we have minus 0.5 rho squared minus 0.5 rho squared. So the profit of the agent is equal to 0. This comes with no surprise because this is intended by the participation condition. So like the principal set up a contract where in the end the agent is stripped. So the agent is naked. The profit of the agent is equal to 0. The profit is 0. Why does the agent sign the contract and excel a positive effort level when his profit is in the end equal to 0? Here we have to look at the different components of the profit function of the agent. So the output generated is equal to 100. It's 10 hours worked times the marginal productivity of 10 is equal to 100. And these 100 units, they go completely into the pockets of the agent. The agent has to pay 50 units as an entry fee in form of the fixed component, and the acceleration of effort leads to some cost also of the size of 50. So when we look at the different components, then it's a case that the agent generates 100 products in the 10 hours of work. The agent had to pay the principal the fixed component of 50 products for the entrance ticket, and this leaves the agent with 50 products. These 50 products compensate the agent for the cost of effort. The agent goes home with 50 products in the pocket, but the agent is also exhausted. What about the profit of the principal? When we once more insert the incentive constraint and the fixed component into the profit function of the principal, we get to this relationship here. 1 minus S is given by 1 minus 1. And then we have here rho times rho. This is the share of the output which goes to the principal. Of course, this share is 0 because of the fact that the whole output goes to the agent. Then in the profit function it says minus the F component, but the F component in itself is negative. Therefore, the profit of the principal is positive. It's a positive 0.5 rho squared. Therefore, the profit of the principal is equal to 0.5 times 10 squared. 10 squared is 100 times 0.5. So the profit to the principal is equal to 50. Let's sum up. The principal does not get a share of the output because the output goes to 100% to the agent S is equal to 1. The principal extracts all his profits via the fixed component, which he receives as an entrance fee from the agent. The principal receives 50 products, the same as in the basic scenario. Therefore, we say that in this basic setting here, it is the case that the principal is able to solve the principal-agent conflict completely. So it is the case that the principal ends up with 50 products, and this is the same as in the basic scenario. The principal is able to solve the principal-agent conflict completely in this basic setup. As a homework example, I suggest that you try to confirm these results of the basic scenario as well as a principal-agent scenario by using the Excel solver. Please set up the spreadsheet and then try to maximize the one or the other function under some sub-constraints, and then you should be able to come up with the same result as received here in this lecture. Thank you very much for attending this lecture. Have a nice day. Bye-bye.